In this video, we're going to talk about linear functions and their properties. So linear functions are something we've seen before, just we didn't call them linear functions. So the definition, a linear function is a function that can be written in the form f of x, so the function, is equal to mx plus b. Okay, now that probably looks familiar. So y equals mx plus b is the formula in slope-intercept form for a line. And in fact, linear functions, their graphs are lines. Okay, so for linear functions, they always have a constant rate of change, so we call that m. Okay, m is the slope, which we sometimes write as delta y over delta x. Okay, or you might say it's y2 minus y1 over x2 minus x1 for any 2 points x1, y1 and x2, y2. If m is positive, then the linear function is always increasing because it's always moving. So if you have a positive slope, okay, that means that your line is going like that. So you're always going up as you go to the right. So as the x values get bigger, the y values also get bigger. If the slope is negative, then it's the opposite. So your function will be always decreasing. Okay, so these are things that we've seen before. Okay, but now we're talking about them as functions instead of just linear equations. I'm going to skip the first example and go right to the second one. So I would encourage you to try this first example on your own and make sure you're comfortable with linear equations as linear functions. So let's get right into example 2 here. So here we have two functions. So f of x is negative x plus 2 and g of x is 1/2 x minus 4. So in the first part, I want to solve for where f of x equals 0. Okay, now remember f of x is like our y value, so I essentially want to solve for where y is 0. So just replace the f of x with a 0. So I want to solve where 0 is equal to negative x plus 2. Okay, obviously this is when x is equal to 2. Okay, so not too difficult, just some notation. So all we did was replace f of x in our equation, okay, so this part, with 0. Okay, so we want to know when is that equal to 0. Now, what if I wanted to know where is it greater than 0? So that's, again, replace the f of x with 0. I'm just going to replace f of x with what f of x equals, which is negative x plus 2. So this is the same as saying, where is negative x plus 2 bigger than 0? Okay, now if I add x to both sides to isolate the x, this is saying 2 is bigger than or equal to x. Okay, so that would be our solution. So in interval notation, we want all x's that are smaller than 2, so from negative infinity to 2, but not including 2. Okay, now for part C, I want to know where are f of x and g of x equal? So I want to know for what x value is this part equal to this part. So we just set them equal to each other. So we want to solve negative x plus 2 is equal to 1/2 x plus 4. Minus 4, sorry. Whoops. Minus 4. Okay, so then I just want to isolate the x, so I'm going to move this x over to this side. And then I'll move the 4 over to this side, so those things are going away. So that's going to give me 6 on the left side. And on the right side, I have 1/2 x plus 1x. That's going to be 3 over 2x. So then I want to divide both sides by 3 over 2 or multiply by 2/3 is the same thing. Okay, and that's going to give me 4 equals x. Okay, so when x is 4, those things are equal. So let's just check. Okay, so f of 4 is negative 4 plus 2. So that's negative 2. And g of 4 is 1/2 times 4 minus 4. So that's 2 minus 4, which is also negative 2. Okay, so you can see they're the same. So at that x value, g and f give the same y value. Okay, now if we graph them, so let's graph them on the same grid here. So f of x has a y-intercept at the point 0, 2 and a slope of minus 1. So I'm going to go down 1 over 1 to get a point, or up 1 over 1 to the left. Okay, so this is my function f of x. Okay, now g of x has a y-intercept of negative 4. Graph this in a different color. Okay, so negative 4 is down here. Okay, and then the slope is positive 1/2. So I'm going to go up 1 over 2 to get a point, or down 1 and over 2 this way. Maybe I should get rid of that. Okay, so then the line connecting those is g of x. Okay, so that's g of x is equal to 1/2 x minus 4. And then where they intersect, okay, so that point here, I mean, it's not exactly on the right point, but where they intersect, this point, notice it's at 4, negative 2. This is where f of x is equal to g of x, right? Remember, it was when x is 4 and y was negative 2 at that point. Okay, so that's the solution of where those two lines are equal. Okay, so if you want the solution where two linear functions are equal, what you want to do on the graph is look for their intersection point. Okay, so that's one example. Okay, let's do one more. Okay, so here's a graph of a linear function. Okay, so they haven't given us the equation. Now we could find the equation. Maybe we'll do it after. But we'll try to answer these questions just by looking at the graph. Okay, so where is x equal to 4? So, or f of x, sorry. Where is f of x equal to 4? So you want to look on the graph. We want to know where the y value, so this is where the y value equals 4. So we look at 4 and then I see, oh, it's right here. Okay, and it has x value 6. Okay, so f of x is equal to 4 exactly when x is equal to 6. Okay, now for part B, I want to know where is f of x, so the y value, bigger than or equal to negative 4. Okay, so we want y bigger than or equal to negative 4. So I look for negative 4. Okay, there's negative 4. So it intersects at when x is 0, and I want the y's to be bigger. Okay, so that's going to be to the right of 0, right? I want the y values to be above negative 4. Okay, so this is going to be when x is bigger than or equal to 0 is going to be my answer there. Okay, now we want to know where is f of x less than 0. So this is when the y value is less than 0. Okay, now the y value equals 0 at 3. Okay, and it's less than 0 when it's below the x-axis. So that's when it's below or less than 3. Okay, so this is going to be when the x value is less than 3. Okay, now I'm not including 3 because it equals 0 at 3, and the inequality here is strictly less than. Okay, in part B, we had less than or equal -4, and it was equal -4 at 0, which is why I included 0 there. Okay, maybe I should have been doing these in interval notation. So this is -infinity to 3, not including 3. And this one is including 0 up until infinity. Okay, so we want x to be less than 3. Orange. Okay, so now I want to know, where is f of x between 0 and 4? Okay, so I want to know where the y values are between 0 and 4. Okay, so it's 0 at 3, and it's 4 at 6. So this little part here is where the y values are between 0 and 4. So that means I need the x values to be between 3 and 6. So the interval from 3 to 6, not including either endpoint. Okay, so that's how we can read from the graph. Now if you wanted the function here, so the y-intercept is -4, so the b is -4. The m is, it looks like I go up 4 over 3, so it's going to be 4/3. So the function, which we didn't need to answer any of these questions, but it's 4/3 x minus 4. Okay, that would be the equation. And you could redo all these problems using the equation, and you should get the exact same intervals. Okay, now again, I'm going to leave number 4 for you to try. It's sort of combining these ideas. We're using equations, though, instead of graphs. But I will fill it in for you in the subsequent video. So those are linear functions.